Hello everyone. In previous lecture we have read about the differentiability of function at any point. So now students, we have read about the definition of continuity of a function and differentiability of a function at any point. Today we will give an example of a function which is continuous at any point but not differentiable at any point. This is also a very important question and concept for differentiability of function. So now suppose if we check a function fx is equal to mod of x. Now this function fx is equal to mod of x. If we check the continuity and differentiability at point x equal to 0. Suppose if we check the continuity and differentiability of this function at x equal to 0. So students, for continuity of this function at x equal to 0, according to we know that there are three cases. For continuity of any function at any point, so we have to find limit of function x tends to 0 plus should be equal to limit of function x tends to 0 minus and is equal to f of 0. So if we solve this value, this is limit of mod 0 plus h, x tends to 0, and here it will be limit mod, this is mod 0 minus h tends to 0 and equal to 0. We know that at 0 plus h, when we put 0, it is 0, this is 0 and this is 0. So we can see all the values are equal is correct. So function is continuous at x equal to 0. So now, but again we will check for same function, is function is differentiable at x equal to 0. So now we will see the definition, we will check the differentiability of function at x equal to 0. So now for this, we know that for differentiability of any function, the right hand derivative of a function at that point and the left hand derivative of the function at that point should be equal. And if it is not equal, these values are not equal, then function is not differentiable. So students, first you will write this continuity quotient, and now we'll check the differentiability. So now for differentiability at x equal to 0. For differentiability at x equal to 0, we have to find first right hand derivative, which is equal to, according to definition, limit x tends to 0 function 0 plus h minus function 0 divided by h. So students, first we will find it in proper way. Limit h tends to 0, f0 plus h is mod 0 plus h minus mod of 0 divided by h. Always remember, h is always very small positive real number, so always remember it. So students, when we simplify it, now it will be limit h tends to 0, mod of h is h minus 0 upon h, and h is cut by h, this is 1, and right hand derivative of function mod x at x equal to 0 is plus 1. So now if function is differentiable, So its left hand derivative, its left hand derivative is also the plus 1. Okay, we will find the left hand derivative. So students, left hand derivative, left hand derivative, left hand derivative is equal to limit f of 0 minus h minus f of 0 divided by minus h tends to 0. So now when we calculate it, limit h tends to 0, mod of 0 minus h minus mod of 0 divided by minus h. According to definition of mod, mod 0 is 0, h is positive number, minus h negative, but mod of minus h is plus h. So limit h tends to 0, mod of minus h is minus h divided by, sorry, plus h divided by minus h. So now when we calculate it, then the answer is equal to minus 1, and which is not equal to right hand derivative. So in this way we can say here the function is not differentiable at x equal to 0, but continuous at x equal to 0. So many functions may be exist here which are continuous at any point but not differentiable at that point. So this is also a very good example for a function which is not differentiable at any point but continuous at that point. So I will write 1, 2, 3 more examples. So you will check the differentiability and continuity of these functions at point. So for example, you can try in your home. The question is, you can try in your home, that is, the function fx is equal to mod of x minus 1 at x is equal to 1. So students, please check this function continuity and differentiability at point x equal to 1. When we check the differentiability and continuity of this function at point x is equal to 1, then we will find that this function is continuous at x equal to 1 but not differentiable at x is equal to 1. So many examples we can make by this. So this is the also very important question. Please remember it and please do this, solve this problem in your home. Now students, one more thing is actually remaining in our syllabus, that is the greatest integer function, the continuity of greatest integer function at any point, at any integer. It is also a very important question. So now one question we will write again, that is prove that function fx is equal to greatest integer function x is not continuous at any integer. Always remember it. This is also the question for 2 marks, 4 marks also. So it is also very important. So we want to prove the function fx, where greatest integer function x, never continuous at any integer point. So students, we can see an example, or we can see, let assume that for solution of this question, assume that let k is any integer. K is any integer. It means k is a 1 of 0, 1, 2, 3, minus 1, minus 2, minus 3, and so on. So now, at k, if we check the continuity of this function, if it is its left hand limit and right hand limit and the value of function are differ to each other, then this function is not continuous at integer k. Okay, so now first we will find left hand limit. So left hand limit is limit of function k minus h minus function, sorry, this is not, it is continuity, limit at h tends to 0. We will find it. So students, now we will write here limit h tends to 0, greatest integer function k minus h. But always remember it, h is a very small positive real number, as small positive real number. So therefore, if we find, for example, 2 minus h, then directly it will be equal to 1, because the 2 minus h means the 2 minus h will be 1.9 something less than 2 value, and the greatest integer value of 2 minus h is equal to 1. For example, 3 minus h, then answer is 2. So this concept should be memorized to us. So now when we find the k minus h answer, then it will be equal to directly h tends to 0, it will be k minus 1. And now limit, we will put limit, then answer is k minus 1. So our left hand limit at integer k is k minus 1. Is it clear to all students? Please again check it, how we can find left hand limit. Now again we will find right hand limit at this point k. So okay, now students, we will find right hand limit at k. So okay, I will write here again right hand limit. Right hand limit is equal to limit function k plus h tends to 0. So now limit h tends to 0, function k according this greatest integer function k plus h. Now again h is very small positive real number, and like 0.1, 0.12. So now k plus h and their greatest integer function, k is integer, so k plus h is like k is any number, suppose 3, then it will be 3 point something. So greatest integer value for this function for this value will be convert this number in k, and the answer will be k. So here we can see the left hand limit and right hand limit at integer k is not equal. Therefore, and definitely if when we find the value of function, and when we find the value of function at point k, and this equal to greatest integer function k, and k is integer, this is k. Okay, right hand limit and the value of function at point are equal, but the left hand limit is not equal. So therefore function is not continuous any integer. So it is also a very important question, students. Please keep in mind always, any function, greatest integer function, is not continuous in any integer. So this is our, so please remember it. Now students, already we have read the definition of differentiability of function and how we will find the differentiation of function by the first principle application. And in the previous class already we have revised the differentiation of some standard function like x to the power of n, sin x, cos of x, tangent of x, secant of x, cosecant of x, cotangent of x. So now this is the time for define the differentiation of composition of function, and it is our previous theory, that is the important algebra of differentiation, in which we have already read in class 11, that is the differentiation of function 1 plus function 2. It means the differentiation of sum of function is directly the sum of differentiation of function. So this is a very important and very easy concept. You know, if it is plus, it is then plus. If it is minus, then it is minus. One more thing we have read in class 11. It is the differentiation of the product of function. We have derived it in class 11. We'll find the differentiation of product of two function, and this has also a particular rule, that is the first function into differentiation of the function 2 plus the differentiation of first function multiplied by function 2 as it is. It can be generalized for 2, 3, 4, 5 functions. It means it will be also, we can write here, if we have the product of 3 functions, suppose anywhere, then it will be equal to f1 dash f2 f3 plus f1 f2 dash f3. Dash means the differentiation of particular function f1 here, function 2 here, and in last function 3. Remaining function multiplied as it is in each term. So this is the rule for differentiation of product of two functions. And one more very important concept we have read in class 11, that is the differentiation of division of function df1 by f2. So this is, in this function it should be clear that function f2 never 0 for any value of x. Then the differentiation of division of these two functions f1 upon f2, this is called numerator function, this is called denominator function. So always remember it, denominator should be first into differentiation of numerator function minus the numerator function will be as it is, the differentiation of denominator function divided by the square of function which is in denominator. This is the formula for finding the differentiation of division of two functions. For example, we want to find the differentiation of sin x divided by x square. So now in this question the answer will be, according to this, denominator x square and the differentiation of sin x is cos x minus the numerator will be as it is, the differentiation of denominator 2x sin x and divide by the square of denominator function, it means this will be the differentiation. And x will be cut from both taken common and cancel out. So in this way we can find the differentiation of division of two functions. Is it clear to all? Is it clear to all, friends? Okay. Now